Houston, we have a problem. And this time it's snowballing out of control. See, just about a week before Christmas, we lost power in the kitchen due to too many small appliances running at the same time. It happens on a weekly basis. Not a big deal. Run down to the breaker panel and flip the breaker on the appropriate circuit that restores power to the kitchen circuit. Not this time, Houston. This is the faulty breaker. This breaker is a switch with only two positions, fully on and fully off. There should be no positions in between, such as this. This breaker lost all its springiness to the lever and is toast. It's 11 p.m. The kitchen is not powered, especially the fridge is not powered. What do? My baby suggested at this point that we grab a long extension cord and restore power only to the fridge by plugging it into an outlet that's on another circuit, and then the fridge will be running at least. I didn't like the idea of restoring partial power to the kitchen and tripping over a long extension cord, so I thought we are just gonna remove one of the breakers from a non-essential circuit, such as living room lights, and swap it up with the kitchen's breaker, and then this way restore power and full functionality for the whole kitchen. That's exactly what I did. In this process, of course, we lose one breaker that's powering living room lights, but not for long, because what's any easier than running down to the store and grabbing one of these? Yeah, or so I thought. This breaker should cost about $10, so I go down to the store the following day with high hopes. This is a Siemens Blue Line 10mm wide, one-phase, 15 amp circuit breaker. It is not available. It has a barcode, it has a price tag. Nobody stocks it on yay side of the Rocky Mountains. It's just not available. So now what do? The price tag is also $70 on this one. All of the breakers have a normal price tag, like $10, $8, $12, something like that. I'm not paying $70 for a breaker with the possibility or potential of I have another 9 breakers remaining besides the 30 amp dryer and the 40 amp range that can also fail. So what do? And the answer is, of course, get a new breaker panel. With a new breaker panel, 2 problems will be solved. All of the breakers will be fresh, will have full functionality, because breaker panels come with all of the breakers that match it, and the new breaker panel will be compliant to the latest electrical codes, unlike this, which is from 1968, maybe 1972. Possibly this was installed on Noah's Ark, was powering it. So that looks like a win-win. 2 problems solved. However, we're not out of the woods. The new breaker panel is longer and is wider. I have a wall stud here. It still doesn't fit from the corner to the wall stud. I either need to notch the stud or move the breaker panel and mount it in the next stud space here. That introduces another problem. The wires leading to this panel may not reach one stud space over, and we don't know until we try. Also, we can't go that way because this is a corner. This is part of a closet that was added later, but I really don't want to go that way with the new wider breaker panel. So one geometric possibility is to get the new breaker panel mounted on the opposite side of the wall in the same space, so at the same height, the same distance away from the corner. This is how it looks like on the other side of things. There, I just cut a hole in the drywall. This plywood is on which the other breaker panel is mounted. You can see that mounting screw there sticking out, and this would just fit here just like so. fully in when the other breaker is disconnected and is out of the way. Looks like a good idea. However, this room here is a laundry room, a wet service environment. Ideally, electrical stuff such as breaker panels shouldn't be in a wet service environment, and so this solution here is less than ideal, but at least I have a good likelihood of the wires reaching and being able to connect everything within a day or so. So what I'm going to do next is disconnect everything on this side so I can see how long the wires actually are, because I might be able to move it sideways here so it's not facing the laundry. We'll see what I can do. My stud layout in the wall here is 16 inches on center, and even if I move the breaker panel to the next stud cavity there, it's 13 inches here, so that leaves me just 1.5 inches on its left and on its right. Not a whole lot of room for running the wires and these clips there on it. So what I might end up doing actually is notch out this 2x6 here, just however long the new breaker panel is, just wherever, notch it out there, cut it up there, so at one point the new breaker panel is going to be balancing on this stud somewhere, and then build a shelf where it can rest on, and these wires here, which are coming from that general direction anyhow, will run down in this stud space and enter the box from that side, and these cables here running on this side will just stay there and just enter the box from this side in this stud space here. And there's enough length in the main line here, which is running there and just goes that way. There's enough length in this so I can just move it over there or wherever it's center going to be on the new one, but it doesn't have to be entering the center of the box. You see, you have multiple options there on it. So that way it's not facing a wet service environment. However, two reasons why I'm still considering this laundry room here. One, this is a heated space. There is no condensation on the walls or on any of the surfaces. This is not a wet, damp basement, okay? This is a heated space with a ceiling fan that I installed and upgraded 2 years ago or so. And the other reason is that this laundry room is not locked. This door is always open and it's easy to open, and there is not going to be anything blocking your way here from accessing the panel here. Whereas on the other side here, this is a tool room with cables and wires and projects and tool chests and whatever else in the way, requiring that you reach over things, or potentially, especially when it's dark, when there's no power, you're tripping over stuff. So that's how the installed breaker panel looks like at the moment. The stud was not notched, so it's between two wall studs. I put another piece of wood horizontally in, the breaker panel is resting on that. Most of the cables enter from the top, some enter from below, and 4 cables enter from the side. I had such a miserable time fitting the panel with the cables running through the holes into the square recess that I cut for it. I had to chew away a little bit of extra drywall there because of those 4 cables. In the end, the faceplate or this cover plate isn't wide enough to cover the gap, so I'm slightly irritated by that. What I'm gonna do is pull those 4 cables, make them enter from the top, fix the drywall, and that way it's gonna look okay. One more thought about switches and the wet service environment. These breakers are switches. There are other switches in any laundry room, in any basement, in any bathroom. So those switches and those contact surfaces aren't any different from those switches and their contact surfaces. So I think this laundry room is a lot drier than a bathroom where there is running water present all the time and moisture saturates the air all the time and there is condensation visible on a daily basis. Here there's none of that. There is running water, it's inside the hoses. There is some water vapor escaping from the washer and from the drying process, but most of them are vented easily either through the dryer's hose or through the ceiling fan. So I think I'll live with this one, other than the drywall edge that's gonna be fixed.